Okay, this video is a explanation of Chapter 4, Section 1, which deals with sampling and surveys. So Chapter 4 in general is about how data is collected. 4.1 is on sampling and 4.2 is on experimental design. And so there's really hardly any math in this chapter. Terminology is important, but it's just on how data is collected and interpreted. And so understanding the terms is very important, the definitions, and I think understanding these concepts is like a lot of things in statistics, really reading different contexts that they are applied in is the way to understand them, and to being able to explain them is being able to explain a context. And your book, once again, does a really good job of showing different contexts in the examples and in the problems, and so that's the best way to understand this stuff to me, or it's certainly one of the good ways. You certainly want to talk about it as well and ask questions about it and do classroom activities and so forth, and watching this video will hopefully help. But to read the different examples and explanations, and then to read the problems and to read the answers in the back of the book, that sort of thing. So memorizing definitions I think does have a value to it, and so I encourage you to do that, but more importantly, being able to apply it in a context is important. So what's happening here is this is what's happening with sampling. We have a population, which I'll represent by this big circle. So let's say that population, every little point in here is, let's say, a voting age person in the city of Huntsville, Alabama. So let's say there's 100,000 voting age people in Huntsville, Alabama. And I could do a census, meaning I could contact every person here. And what I want to know is let's say the proportion that are going to vote for a certain candidate for mayor. Now, but it may not be practical for me to do a census. So what I'm going to do is I'm going to take a subset of this population, which we call a sample. Okay, and let's say my sample size is, let's say I get 100 people, and so that's our little n, our sample size. And our big N, that's our population size, so let's say it's a total of 100,000. And so what this chapter really gets into a couple things. How did I get my sample? Is a huge issue. And what we want to do is to get it randomly. In other words, we want every one of the 100,000 people to have a chance to get in there, and all of them should have an equal chance, and that's what random means. And secondly, how did I collect my data from these 100 people? So how did I get my sample, and how am I treating them? And we don't want any bias in either of those two situations. So other examples of population certainly doesn't have to be people. It could be things. I mean, it could be, let's say there's a shoe factory, and so a population is all of the shoes in the shoe factory, and I take a random sample, and we'll describe how to do that, and I'm going to measure 100 and get what we call a statistic. Or it could be the population is every tree in this forest, and here's my sample of 100 trees. So anyway, so first of all, let's talk about some terminology, and that's kind of what I said before. All this terminology is important, and reading your book is really going to help you out. So let's look at some definition of some terms, and your book kind of defines these using maybe a little different language. And anyway, so the first thing is, like I said, the population. A population is the entire group of people, animals, or things that you wish to know something about. It's the whole group you want to know something about. All right. So then we take a sample. A sample is just the subset of the population that I'm actually studying. All right. Now, a census. A census is when I survey every person or every animal or thing that is in the population, and I measure it. So frequently a census isn't practical to do, but sometimes you can. Now, the way we get our sample, we want to get it randomly. And we'll talk about exactly how to pull this off, but a random sample simply means that every member of the population is equally likely to be chosen. It doesn't mean haphazard. It doesn't mean just kind of, to walk around and, this person's in my sample and this person's in, just kind of select them sort of haphazardly. That's different from random. Random takes a lot of work. Random, and we'll describe how to do that, but every member of the population is equally likely to be chosen. There's kind of different ways you can do that. The first is what is known as a simple random sample. And simple random sample basically means you haven't had any grouping, which we're fixing to talk about. But technically, and you sort of need to memorize this definition here, simple random sample is represented by SRS, so you'll be seeing that a lot throughout the year. but it's when every group of size n, and that is our sample size. So in this example here, our sample size is 100. So in that case, every group of size 100 is equally likely to be chosen. In other words, there's no grouping in essence. So it is, it's more of a specific version of a random sample. Now, what is a stratified sample? So we have a couple of different grouping strategies. A stratified sample, it's when you divide your population into homogeneous groups and select some from every group. This is best to do when you notice that the group differ in regards to the relevant issue and will result in less variability in responses. So let's say in your population here, in our little population, we have a reason to believe that the males and females are going to differ in regards to what we're measuring. Let's say the proportion that are going to vote for a candidate. If I want a more precise answer, what I'll do is I'll do a stratified sample. I'll randomly select, let's say 50 females, and I'll randomly select 50 males. And those are my groups, or my strata there. And like I said, the reason you would stratify would be if you have reason to believe that your groups differ in regards to opinion. You say, we think they differ. We want to make sure the males and females are equally likely, to be chosen. But there's certainly a number of different things you could stratify on. You could stratify on, let's say, what part of the town that people live in, making sure you get equal numbers from equal part of the town. Or people of different ages. Maybe you have reason to believe that older people are more likely to vote for the candidate than younger people. You could stratify on race, okay? I mean, there's almost an indefinite number of variables you could stratify on, and it takes more work to do it. So you need to have a reason to do it. The reason for stratifying is if you feel there's a difference in the groups. If you have no reason to believe there's going to be a difference in the groups, then there's no reason to stratify. And the result will be less variability in the responses. And that's something we're going to practice in class. And so, what is in essence happening here is there's two things we're sort of can be estimating. There can be a proportion. So we're going to get a statistic, what we call a p-hat, a sample statistic. And it's going to estimate a proportion p. All right, so the proportion P in this case would be the proportion of all 100,000 people that are going to vote for the candidate. So what we're getting is we're estimating that. And what we're doing is we're estimating that with a p-hat. That is the proportion that are in my sample that are going to vote for the candidate. And so this is estimating that. If I stratify properly, my p-hat is much more likely to be closer to p. Similarly, if we were doing with a quantitative variable, let's say a mean, we wanted to know, let's say the mean income of these 100,000 people, and we wanted to know that mu, we would estimate that with a sample x bar. Okay, and we want our x bar to be as close as possible to mu. So one method that we use is by stratifying properly. If we stratify properly, all right, our x bar is much more likely to be closer to our mu, and our p-hat's much more likely to be closer to our p. Okay, all right, the next concept is what is known as cluster sampling. Cluster sampling is when you divide the population into heterogeneous groups. All right, that means the groups are sort of representative of the whole, and select one or a few of the groups to represent the whole. So, an example of that we've had, like let's say if you wanted to survey, let's say the senior class at Grissom High School, one thing you could do would be to just take one of the homerooms, because the homerooms are listed alphabetically, and more than likely your variable is not going to be associated with the first letter of people's last names. And so let's say you wanted to know the average height of the students at Grissom, of the senior class. So you could randomly select one of the groups to stand for the whole. All right, now in understanding the difference between stratified sampling and cluster sampling is something we're going to look at examples in class. So let's say you have a population which I'm going to represent, and your population is in groups, and you want to know the percent. What you're trying to estimate is the proportion that are going to vote for a candidate. And you look at your population, it has groups like this. In this group, R stands for the Republicans, and D stands for the Democrats, and L stands for Libertarians, and O stands for other. That is the political groups that have been identified in essence there. If you look at it and your groups look like this, it's best to stratify. It's best to get some from every group. Okay? And so that's what stratifying is. It means getting some from every group. And if you look and you say, whoa, there's going to be a big difference in the groups in regards to the percent that are going to vote for this particular candidate. Let's say he's a conservative candidate, so the Republicans are much more likely to vote for him than the Democrats. Okay, and so you would get some, if you look, and that's what homogeneous means. Homogeneous means it's the same within the groups. So if you have homogeneous groups, you need to stratify. In other words, get some from every group. Whereas if you look at the groups and they're heterogeneous, in other words, they look like this, all right, you notice each group is heterogeneous. It has some Democrats and some Republicans and some Libertarians and some other. All of them are that way. Okay, if you look and there's heterogeneous groups, one option would be to cluster sample. Cluster sample means to randomly select one of the groups to represent the whole. So in this case, you could just take one of the groups and say, I'm just going to measure this group since they're all heterogeneous. And so that would be an easier thing to do than other sampling methods. Now, you have to have reason to believe that the groups really are heterogeneous in regards to the relevant issue, which in this case is the proportion they're going to vote for this candidate. So anyway, so stratified sampling means dividing into groups, get some from every group. Cluster sampling, divide into groups, and to randomly select one group or a small number of groups to represent the whole. All right, so, okay, now, so those are our major sampling methods that you have to be able to understand. All right, then we have what is known as bias. Bias is when certain outcomes are systematically favored, and there's a number of different ways that bias can occur, and your book does a really good job of showing these things to you. Let me say this. When you're given a bias situation, one of the main things you've got to be able to do is when you're asked to explain a bias situation is you must be able to explain in which direction you think the estimate will be off and why. So let's say let me show you what I mean. Let's say I want to estimate this. Let's say I'm estimating a proportion. I want to know the proportion of students that own a graphing calculator. And so what I do is I estimate this with a p hat, and I obtain my p hat by sampling the students near my room. I go stand outside of my room in the hallway, and I find the proportion of students outside my classroom on a graphing calculator, and then I use this to estimate that. Now that would be what we call a convenience sample, and what I would need to be able to say is this. My p hat is probably going to be too high of an estimate for p because my students are much more likely to own a graphing calculator because it's required for our class. Okay, so I've clearly explained how and why the estimate will be off. Or let's say I stood outside of my classroom and I wanted to know, let's say, the mean weight of the students at Grissom. And so I just took the first 30 people that walked by and found an X bar, the mean weight of the 30 in my sample. And I'm using that to estimate mu. Well, that's a biased situation because around my classroom, it's mostly seniors. And seniors are older and more likely to be heavier than the whole classroom. I'm going to get basically no freshmen probably in my sample, thankfully. But anyway, so the way I would explain that, the bias in that situation is, I would say the estimate I'm getting is probably going to be too high of an estimate because I'm only getting seniors and they're more likely to be heavier. So whenever you're asked to describe a biased situation, always explain how you think the estimate will be off. So, okay, so let's talk about different bias situations. One of the things, and I mentioned this is convenience sampling, is just selecting those members of the population that are easiest to sample. So you'll see, someone standing in the mall, and whoever walks by gets to be a part of the sample. Or like, let's say you've got a truck full of potatoes and you want to do the mean weight of all the potatoes. As opposed to taking a random sample, you just take the first 50 potatoes off the top, okay? So that would be, in essence, a convenience sample. Then we have a voluntary response situation. Voluntary response is allowing the members of the samples to select themselves. And so this typically is going to result in emotional negative answers. So like telephone call-in shows that do this thing, there's certainly a voluntary response, or internet polls where they're choosing themselves to do the sample, their voluntary response. Voluntary response typically is going to generate very negative and very passionate answers. And so if I want to know the percent of parents that are upset about, let's say, our new dress code policy, if I go just strictly on the basis of who calls the front office, my p hat, let's say the proportion that don't like the new dress code policy is probably going to be much greater than the actual value, which is all the 1,800 sets of parents. Because why? Because in order for them to call, they have to be motivated to call. And if they're apathetic about it, or if they like it, they're a lot less likely to call. So my IP hat is probably going to be way too high. It's going to be biased too high. Okay, so any voluntary response, internet polls are typically going to be way off. Okay, because it's in order for them to motivate them to do it, they have to be emotional and potentially negative about it. So that is sort of a popular question. Other things that can happen: under coverage, when some members of the population cannot be in the sample. You do a sample of the students of a school, and you do it on a Friday when, let's say the ROTC is on a field trip. Okay, so they had no opportunity to be in your sample. Well, you would say you undercovered the ROTC people, or let's say you just did it on my side of the school, which has no freshmen, thankfully. All right, but if you just took your sample from my side of the school, you would say, well, you're undercovering the freshmen. I'm just kidding. I don't hate freshmen. Anyway, all right. So then another bit of terminology: non-response and this is a big-time problem in sampling. When a member that has been randomly chosen does not respond, a lot of times people don't want to talk. And of course, the problem with that is there could be a difference in the people that don't respond than those that do. So if ever you randomly select a sample, you have to work hard to try to get everybody that's been selected to be a part of your sample. And if you ever get randomly selected to be in a national sample, they are going to work really hard to make sure you reply. And you can't just say, well, go pick that up person over there. You know, he likes talking at something like this. Well, you can't do that because the people that don't respond could be different systematically. So they will work very hard to get you in the sample. Now, this is maybe the most obscure thing in the chapter, and that is the concept of response bias. Response bias just means when there's something in the setting or there's something about the situation that is causing the members of the sample to respond incorrectly. So that's something like, let's say if there was a police officer doing a survey in regards to, let's say, criminal activity. Well, the problem is there's something, people aren't going to admit to a crime in front of a police officer. Or let's say, we did a survey years ago where we surveyed our homeroom in regards to like alcohol and drug activity, and it was known that the parents were going to see the results of this survey. That is a response bias. No one's going to be truthful there if they do alcohol or drugs, because they know their parents are going to read this. But most of the time, it's much more subtle than that. There can be, the way that the interviewer asks the questions, the tone of voice, and even subtle things like the way the interview is dressed. And your book does a good job in examples and problems of describing that. We're going to talk more about that in class, certainly. All right, so one of the main skills you have to be able to do. This is on the exam every year, and that's to be able to clearly state how you would randomly select. It's not hard to do, okay, but this will be on the exam, so you've got to do these 3 steps. All right, so our first problem here says this. There are 1,800 students at Grissom. You wish to know the mean amount of time they sleep each night. So that would be a mean, a population mean. All right. You decide to take a simple random sample of 30 of them. Describe how you would select the 30. And so, all right, this is how you randomly select. Randomly select means all 1,800 are equally likely to be chosen. And there can be different ways of doing this, but here's sort of the most basic way. Simple random sample. Step 1. Give each of the 1,800 students a unique integer between 1 and 1,800. Now, by the way, the reason I wrote it like this is if you use a random digit table, you would have to use this. And I'm not going to do an example of that right now, but your book talks about it, and we're going to do it in class. But anyway, the key thing here is that you say a unique integer. There can't be any repeats. Okay, no person can go more than once. So you have to say unique integer or distinct integer or ignoring repeats. That's important that you say that. But all the 1,800 students get a unique integer from 1 to 1,800. Step 2, using a random number generator, or you could use a random digit table if you wanted, and I'm going to show you how to do that. Create 30 unique integers from 1 to 1,800. Okay, and it has to say unique or distinct or ignoring repeats. Okay, if any, you can't have any repeats. Okay, and then step 3 is you have to say, and a lot of people will forget this step, it's the students with those 30 integers that are in the sample. It's not the 30 numbers that are the sample, it is the students. So you have to say those 3 things. Let me show you how to use random integer with your calculator. So I am going to show you how to do that. So this is what we'll do. And I'm going to go ahead and I'm going to put the random integers in a list. And so what I do to access a list is I'm gonna hit Stat and Edit. Let me clear out my list by hitting Clear and down arrow. Okay, and then I'll just highlight the top of list 1 right there. Now I'm gonna go to random integer is on the Math menu. So I'm gonna go Math, and then I'm gonna arrow over to Probability, and then go down to there, random integer. By the way, you can use random integer, no repeats. I'm not gonna do that now, but because not all calculators have it. But that would actually be a better option. But right now, just random integer. So I hit random integer, and what I'm going to hit, the lower value is 1, the upper value is 1800, and then I'm going to select, and I want 30, but I've got to ignore any repeats. So I'm going to go like 40, and the first 30 unique ones are going to be in the sample. And so I hit paste. And so there we go. The person with that has label 1474 is in the sample. That has 1070s in the sample, and I keep going until I get 30 of them. And so that's how you would use random integer with your calculator. So that is on the exam every year, and you're going to get that right. It's not hard to do. So anyway, all right. Context number 2. So let's see if we can handle this. A scientist named Franz is studying the bats in a large forest in Honduras. He wishes to estimate the proportion, so we're estimating a proportion of the bats that eat berries from holly trees in the forest. When looking at a bat, the scientist can tell if the bat eats the holly berries because they turn its little whiskers into kind of an off yellow color. He has reason to believe that there may be a difference. A difference between the male and female bats in regards to the proportion that eat these berries. The scientist wants to take a sample of 200 bats. All right, so first of all, it asks us to identify our population, our sample. The population is the whole group you want to know something about. And the whole group we want to know something about is all the bats in this forest. That is our population, not any other type of animal, and no bats outside of the forest. That's the group we want to know. And what is the sample? The sample is the 200 bats that are in the sample. Okay, of course. Now, question 2, describe a good sampling method for Franz. Well, we want a random sample, certainly, but also the other bit of information is this. He has reason to believe that there may be a difference in the males and females bats. And so, therefore, we should stratify. We should say to ourselves, wait a second, there's a difference in the males and females in regards to this issue. We need to make sure that the males and females are equally represented. We don't need to stratify on any other issue because we have no reason to believe that any other issue is relevant to this, such as the size of the bats or the age of the bats or anything else, the color of the bat's fur or something. No other variable except for male and female. So what we're going to do is a stratified random sample. And so here we go. Because it is thought that bats of different gender have different portions that eat the berries, the relevant issue, this sample should be stratified on gender. And this is how I would describe that. So for our first strata is the males. Among the male bats, give each a unique integer from 1 to the total number of male bats, which we don't know. Use a random number generator to create 100 unique integers from 1 to the total number of male bats, and then these bats are in the sample. Notice, it said it wants 200 bats, so we need 100 males, 100 females. Similarly, among the female bats, give each a unique integer from 1 to the total number of female bats. Using a random generator to create 100 unique integers from 1 to the total number of female bats. The bats with these integers are in the sample. So that is how you would describe a stratified random sample right there. Why do we stratify? Because there's a difference there. All right. Now, context 3, which is also a stratified situation. An owner, her name is Thelma, of a large apartment building, wishes to sample the people that live in the building. She wishes to know the mean. So we're estimating a mu, a population mean, the mean income of the residents. She has reason to believe that each of the 30 floors of the building is made up of people that have similar incomes. People from different floors are likely to have significantly different incomes. There are 20 people living on each floor. She wants a sample of 60 people. Describe a method Thelma should use. Well, because people on different floors are likely to have different incomes, we need to make sure to get some from every floor. The floor should be equally represented. And so we should do a stratified sample by floor. It says there's 30 floors. We want a sample of 60 people. So if we get 2 people from each floor, it would give us our sample of size 60. All right, and we have exactly 20 people on each floor, which is convenient. That way we won't have to prorate it in any way. And so here's the answer to this. We will do a stratified random sample. Each floor will be a stratum or a group. In each floor, put the names. Now, by the way, this one uses the hat method. The hat method means you just write everybody's name or number on a piece of paper and make sure that the paper sizes are the same size and that they're well mixed, and take out pieces of paper. I encourage you to, when you're asked to randomly select something, to use the hat method, all right, because people are less likely to make a mistake with it. And it's what I would do. It's just a little bit easier to write. You have to know how to do what we just did in regards to the numbering and all that. But this is probably the easier way. And you've been asked to do the other way on the test. But anyway, so each floor is that. I mean, each floor, put the names of the 20 people on 20 pieces of paper that are the same size and well. You have to say same size and well mixed. That's important. Okay? That takes care of your randomness, by the way. Randomly select 2 pieces of paper. The 2 people whose names are on the piece of paper are in the sample. Don't just say these pieces of paper in the sample. It's the people that are in the sample. Okay? You do this for all 30 floors, resulting in a sample of 60 people. So there we go. And then lastly, let's look at context 4. Benito wishes to take a sample of 25 of the 12th grade students at his school to find out their opinion about the new dress code policy that the district has made. He notices that the 400 members of the senior class are divided into 16 homerooms alphabetically, and each of size 25. Students in a similar place in the alphabet would be in the same homeroom. What type of sampling method should he use? So he notices we have groups, each of size 25. There's 16 different groups of size 25, and they're heterogeneous groups. They're lined up alphabetically. There's no reason to believe that this issue, which is their opinion about dress code policy, is in any way related to people where they are in the alphabet. So he's got something what he could do is just take one of the homerooms to represent the whole. And that's what we call cluster sampling. All right. So Benito should use a random cluster sample, and it's random because I'm going to randomly select one of the homerooms. Okay. And so thus all 400 students are equally likely to be in the sample. Thus it is random. Okay. Benito should use a random cluster sample, as each of the homerooms should be a heterogeneous representation of the senior class in regards to dress code opinion. He should give each homeroom a unique integer from 1 to 16 using a random number generator to create a unique integer from 1 to 16. The homeroom with that integer makes up the entire sample of size 25. Okay, that's it. That's my description of the concepts of Section 4.1. I encourage you to do a good job of reading that and the various contexts in that regard. So thanks for watching the video.